Before we get into the details of ionic bonding, we first need to review a few definitions. First, a bond is the forces that hold groups of atoms together and make them function as a unit. Bond energy refers to the energy required to break a chemical bond. And finally, the octet rule says that atoms will gain or lose electrons in order to have a full outer or valence orbit of 8 electrons, just like noble gases. There are two main types of bonding, ionic bonding and covalent bonding. In ionic bonding, one atom has a stronger attraction for electrons than the other and will steal an electron from the second atom. This is always between a metal and a nonmetal. In covalent bonding, the attraction for electrons is similar for the two atoms. That means that they will share their electrons in order to obtain a full octet. This always occurs between two nonmetals. Now in this video, we're going to focus solely on ionic bonding. So looking at ionic bonding further, ionic bonds form between a metal ion, which is always the cation, it takes on a positive charge, and a nonmetal ion, or the anion, which always has a negative charge. When a neutral atom loses electrons, it becomes positively charged, or the cation. That means that the metal is always going to lose electrons, and if you have 4 or less electrons in the outer orbit, that means that those atoms are always going to lose their electrons in order to form a cation. When a neutral atom gains electrons, it becomes negatively charged, which is our anion. Electrons are gained when an atom has 4 or more electrons in its outer orbit. So these are always going to be your nonmetals. And once the cation and the anion are formed, the ions are going to attract one another to form an ionic bond. So an ionic bond is an attraction between a positive and a negative charge ion. There are two ways that we can represent the formation of an ionic bond. The first is using ionic diagrams. What we're going to do in an ionic diagram is we are first going to draw Lewis diagrams of the metal and the nonmetal. We're going to show the electron transfer using an arrow from the metal, because the metal is donating electrons, to our nonmetal, which is accepting the electrons. And we're going to end off our ionic diagram by drawing our two atoms. We're going to use square brackets around each of our ions to represent stability. And we're only going to draw the Lewis diagram for the anion. Let's take a look at an example then to see what this looks like. In this example, we're going to look at the ionic bond that's formed between lithium and chlorine. Our first step then is we're going to draw out our metal lithium and our nonmetal chlorine, and we're going to draw the Lewis dot diagrams for each. Lithium has 1 valence electron, so we're just going to draw 1 electron for it, whereas chlorine has 7. So we're pairing them up on each of the 3 sides, and then 1 on one side. The second part of our ionic diagram is we want to show how the electron is transferred. It is donated from the lithium to the chlorine. So we're drawing an arrow from the 1 electron on lithium to where it's being donated to for the chlorine. Where they're going to draw an arrow because the electron transfer has happened. We're going to then do lithium in square brackets and put its charge at the top. It forms a +1 charge. Chlorine forms a -1 charge. And then we're going to draw the 8 electrons now in the valence shell for just the chlorine, just the anion. We don't need to show the lithium. The second way that we can represent an ionic bond is through a series of ionic equations. Ionic bonding involves 3 steps or 3 energies, and we can write an equation for each. The first involves a loss of electrons by one element, and when we lose electrons, that's known as our ionization energy. The second involves the gain of electrons by the second element, our nonmetal. That's known as our electron affinity. And finally, we can write an equation to show the attraction between the positive and negative charged ions, which is our bond energy. If we look at an example then, we're going to look at the example between calcium and fluorine. We can write out 3 equations to show these 3 steps. Our calcium is our metal, is going to lose electrons. So we're going to write calcium, and this is going to require energy, which is the ionization energy, to create a calcium with a 2+ charge, because recall calcium has 2 valence electrons, and it's going to release 2 electrons. Both of these are going to get donated to our nonmetal. Our second equation then is going to show our fluorine gaining electrons. Now remember, fluorine's a halogen, so it's got 7 valence electrons. Each fluorine can gain 1 electron from a calcium. So to represent that, we're going to do fluorine plus 1 electron reacts to give an F1-, and by gaining the electron, it releases some energy, which is our electron affinity. Finally, we're going to show how these two ions combine together to form our ionic compound. So we're going to take 1 calcium with a 2+ charge, and it's going to be combined with 2 fluorine ions in order to form CaF2, or calcium fluoride. So this final equation here shows how the 2 ions come together, these 2 ions come together to form our ionic compound.